For decades, scientists have quarreled about how these strange landforms were created. These elliptical, shallow depressions highlighted by LiDAR remind me of looking at a map of the moon or Mars. But this isn't a faraway planetary surface. It's Nebraska, and this is South Carolina. These landforms appear all over the East Coast, and these are the Carolina Bays. And I'm probably going to make some enemies with this video, but I'm going to describe the two main hypotheses for how these formed and then tell you why I think one of them falls apart. In the end, you get to look at the evidence and decide which explanation makes most sense to you. Let me know what your conclusion was in the comments. But first, let's get to know the Carolina Bays better. Carolina Bays are oval-shaped, shallow depressions that often host shallow ponds or swamps, making them a really important wetland system for animals and plants alike. The bays can be found all along the Atlantic coastal plain from Florida to New Jersey, and one study estimated a total of 40 to 50,000 of them just between Virginia and Florida. Recently, some Carolina bays have been found in Nebraska as well. And the orientation of the bays, at least on the Atlantic coastal plain, are northwest to southeast, and they generally have raised sandy rims on their eastern and southeastern edges. These unique geomorphic features were first observed back in 1848, and scientists have been arguing about how they formed ever since. There are basically two schools of thought about how they formed. So let's discuss each, and you can decide which one you think is the most likely origin story for the Carolina Bays. The first theory I'm going to talk about is the meteorite impact theory. I mean, just look at these things. They look like they're swampy versions of the craters you might see on Mercury, the moon, or Mars. And countless scholarly articles have been written suggesting that these are actually impact craters. And one of the most outspoken proponents of the theory is Dr. Antonio Zamora, who takes this impact theory one step further. He noticed that not only are the bays elliptical, Zamora suggests that these are secondary impact craters because the elliptical shape of them suggests an oblique impact direction. And primary impactors usually have a steeper impact angle. He recently took LiDAR data from Nebraska's Rainwater Basin and noticed that the bays in Nebraska are oriented northeast, while the ones in South Carolina and along the coastal plain are oriented northwest. So they both point towards the Great Lakes region. Zamora hypothesizes that a giant impact hit the Great Lakes region during the Ice Age, so it actually hit the Laurentide ice sheet, roughly 140,000 years ago. He suggests that this impact blasted giant blocks of ice over 1,500 miles away to create these secondary impact craters in a semicircle around the impact point, creating the bays that we see today. So that's theory number one on how the Carolina Bays formed. Let's move on to the second theory. The second main hypothesis is not quite as exciting as an impact theory, but it's no less worth considering. This idea suggests that the Carolina Bays aren't craters at all, but rather the remnants of thermokarst lakes reshaped by wind. During the last ice age, huge swaths of North America were locked in permafrost or seasonally frozen ground. In the regions where we see the Carolina Bays today, the Carolinas, Georgia, and even parts of Nebraska, show multiple lines of evidence that they sat on the southern fringe of that permafrost zone. When the climate began to warm, the frozen ground didn't melt gracefully. It slumped. In permafrost landscapes, when buried ice thaws, the surface collapses into shallow, irregular basins called thermokarst depressions. Think of the ground literally sagging once the ice inside of it disappears. Almost like freezing an old sponge, letting it out to thaw, and seeing it droop. And according to a USGS paper, Carolina Bays likely started as these thaw collapse basins during cold Pleistocene intervals. Once the basins formed, they behaved like shallow lakes and wetlands. And it's at this point that the wind would take over. During cold, dry, and windy periods of the late Pleistocene, strong winds would push water and loose sand around the basin edges. And over thousands of years, the storms gradually piled sand into these raised rims, especially along the downwind side of the bay. And in the case of the bays along the Atlantic region, that would have been the eastern and southeastern margins of the bays. Instead of a single catastrophic moment, they grew through repeated pulses of wind-driven reworking and a freeze-thaw cycle. And here's the part that really challenges the impact theory. When scientists drilled cores into the bays and the rims of the bays, they didn't find chaos. No fractured layers, no mixed up sediments, which are hallmark characteristics of impact craters. Instead, they found undisturbed, orderly sequences. A few meters of sand or muddy sand sitting neatly on top of older, finer-grained material. And that's exactly what you would expect from slow lake and wind action, and exactly what you would not expect from a catastrophic meteorite impact, even if it's from a chunk of ice from an ice sheet 1,500 miles away. Other studies carbon dated the organic rich soils underneath the bays and found an age range between 8,000 years old and 45,000 years old. And that's not because of uncertainties in the carbon dating, that's because the ages themselves of the bays varied that much. So that's a huge spread, which strongly suggests that these formed episodically over time, over multiple cold periods throughout the late Pleistocene. And now that I've laid out each hypothesis and given you a chance to consider which one you think is the most realistic origin story for the Carolina Bays, it's time for me to weigh in with my 2 cents and make a few enemies while I do it. Because I know a lot of people really like this meteorite impact theory, but if you start pulling that thread, that sweater starts unraveling very quickly. Firstly, the math ain't mathin' with the meteorite impact theory, and I'm gonna tell you why. If the Carolina Bays are actually secondary impact craters, that means you would have had to have an impactor large enough to hit the Laurentide ice sheet and launch ejecta over 1,200 miles away, which means that you would have had to have an enormous primary impactor. I've run the math, and the impactor would have had to have been as large as the impactor that resulted in the demise of the dinosaurs. What do you think would have happened to the ice sheet if something that large hit it? It would have carried an immense amount of energy, which would have melted the ice, and we don't see catastrophic, large-scale flood events on North America that support that hypothesis. But let's assume that somehow an impactor that large hit the ice sheet and the ice sheet was fine, and we had giant blocks of ice flying through the air for 1,200 miles at least. What do you think would have happened to those chunks of ice in the air? Oh, they would have melted. Most ejecta that would have traveled at those types of speeds would have become molten, pulverized, or completely vaporized. So it's unlikely that the ice would have survived the journey. But let's just say a giant block of ice made the journey somehow without vaporizing, we would have seen extreme disturbance of the crater itself. You would have seen the material inside the crater essentially overlapping the material outside of the crater, and we just don't see that in core samples. So if I'm so critical of this meteorite impact theory, what do I think happened? I'm a proponent of the thermokarst and wind action theory. The one thing that isn't considered in that theory is the consistent orientation of the bays. However, there are studies of Siberian thermokarst lakes that show very consistent elliptical shapes in thermokarst lakes. Upwards of 56% of the lakes in thermokarst regions are elliptical. However, only 2 to 4% of impact craters on Mars are elliptical. So for me, as an ex-meteoriticist and ex-planetary scientist who's looked at a few impact craters before, the most plausible explanation to me is the thermokarst theory. So how do you think that these things formed? Let me know in the comments below, which theory do you think is most likely, or is there another theory that you think we should be considering? I'm the Cosmic Geologist, and if you like to talk about science from the crust to the cosmos, hit that subscribe button and I'll see you in the next video. Or I won't, because I bet a few of you won't like me after this one. But that's okay. Carolina.